Bismillahirrahmanirrahim. Assalamu alaikum. Students, we were discussing about the water-soluble vitamins. Today, the vitamin for the discussion is the vitamin B6. Vitamin B6, also called as the pyridoxine. Actually, vitamin B6 play a key role in the amino acid metabolism, being required in the several reactions for the synthesis, catabolism and interconversion of the amino acids. The major sources of the vitamin B6 are the whole grain cereals, wheat, corn, nuts, meat, liver and fish. RDA 1.6 to 2 milligram. There are the 6 major compounds having vitamin B6 activity, and these are the pyridoxine, pyridoxal, pyridoxamine and their 5' phosphates. These are the 6 compounds having the vitamin B6 activity, and these are the structure of all the compounds having the vitamin B6 activity: pyridoxine, pyridoxine phosphate, pyridoxal, pyridoxal phosphate, pyridoxamine, the pyridoxamine phosphate. All forms of vitamin B6 are the pyridine derivatives. They differ only one another from each, but they differ from one another only in the nature of the functional group attached to the pyridine ring. Pyridoxine occurs primarily in the plants, while the pyridoxal and the pyridoxamine obtained from the animal sources. Pyridoxine can be converted to the pyridoxal and the pyridoxamine. It is a point to be noted that pyridoxine can be converted to the pyridoxal and the pyridoxamine, but the latter two cannot form the pyridoxine. These are the structure of the vitamins of the vitamin B6. Pyridoxine, it's having the primary alcohol, the functional group, while in case of the pyridoxal, the functional group is the aldehyde, while in case of the pyridoxamine, amino group, and it is the coenzyme form or the active form of the vitamin B6 or the pyridoxine is the pyridoxal phosphate. Active form or the coenzyme form of the pyridoxine is called as the pyridoxal phosphate, abbreviated as PLP. Absorption and transport. Vitamin B6 is rapidly absorbed from the intestine by the passive diffusion. This absorption is highly efficient. About 80% of the ingested vitamin is absorbed. Phosphorylated pyridoxine vitamins are hydrolyzed by the intestinal membrane. Alkaline phosphatase and dephosphorylated forms are absorbed. The major circulating form of the vitamin B6 is the pyridoxal phosphate. It is produced from the absorbed pyridoxine and pyridoxamine, while the pyridoxic acid is the principal excretive form of the vitamin in the urine. 80% of the total limited storage of the pyridoxine is possible, while most of the body stores of the vitamin B6 are associated with the enzyme glycogen phosphorylase. Here is showing the mechanism of the interconversion of the vitamins and the absorption and the transport and the excretion of the pyridoxine. Pyridoxine, with the help of the oxidase enzyme, converted into the pyridoxal, and kinase enzyme converted into the active form, that is the pyridoxal phosphate, while the pyridoxine also converted into the pyridoxamine with the help of the kinase enzyme converted into the pyridoxamine phosphate, and oxidase convert it into the active form of the pyridoxine, that is the pyridoxal phosphate. However, pyridoxic acid is the excretory form of the vitamin in the urine. Role of the vitamin B6. The pyridoxal phosphates serve as a coenzyme for many enzymes involved in amino acid metabolism, especially the transamination, deamination, decarboxylation, and condensation. Pyridoxal phosphate is a cofactor for the glycogen phosphorylase in both liver and muscles and favors the glycogen lysis. However, the steroid hormones, it is also the important function of the vitamin B6. Steroid hormone, it is important in steroid hormone action. Pyridoxal phosphate removes the hormone receptor complex from the DNA binding, terminating the action of the hormones. In case of the vitamin B deficiency, there is increased sensitivity to the action of the low concentration of the estrogen, androgen, cortisol, and the vitamin B. Another role of the pyridoxine is the conversion of the tryptophan to the niacin, that is, the vitamin B6 is also required for the synthesis of the niacin of the tryptophan and the protein. Various reaction catalyzed by the pyridoxal phosphate. First is the transamination reaction. In transamination reaction, there is a transfer of the amino group to the keto group or the keto acid to the amino group. Here there is a this reaction. In this reaction, there is a link between the amino acid metabolism and the carbohydrate metabolism. Basically, the amino acid is converted into the keto acid, and which in turn into the TCA cycle, and it is completely oxidized and releasing the carbon dioxide and the energy. And you can say this vitamin also involves a function having energy releasing vitamin. You can say it is also the energy releasing vitamin. Deamination in transamination reaction, most important enzyme is the AST and also the ALT. And in complete detail, we discussed about these two vitamins, about these two enzymes in the topic of the enzyme biochemistry. Deamination, the conversion of the serine into the pyruvate with the help of the enzyme serine dehydratase. Decarboxylation. In the decarboxylation, all decarboxylation reaction of amino acid metabolism require the pyridoxal phosphate. For example, histidine is converted into the histamine and release of the carbon dioxide with the help of the enzyme histidine decarboxylase. While in the condensation reaction, the most important example is the enzyme delta amino levolinate synthase catalyze the joining of the glycine and the succinyl-CoA for the formation of the delta amino levolinic acid. It is the first reaction in the heme biosynthesis, which is the rate limiting reaction in heme biosynthesis. So you can say if there is a deficiency of the vitamin B6, so it also accounts for the anemia. Deficiency, the deficiency of the vitamin B6. Although clinical deficiency disease is rare, there is evidence that a significant proportion of the population has the marginal vitamin B6 status, while moderate deficiency results in the abnormalities of the tryptophan and methionine metabolism. Increased sensitivity to the steroid hormone action may be important in the development of the hormone-dependent cancer of the breast, uterus, and the prostate, and the vitamin B6 status may affect the prognosis. Drug interactions. Isoniazid is a drug which is used in the treatment of the tuberculosis. However, during this drug utilization, it can induce a vitamin B6 deficiency by forming an inactive derivative with the pyridoxal phosphate. So it is necessary that during the treatment of the tuberculosis, while isoniazid is using by the patients, it is necessary to implement the dietary supplementation with the B6. Its deficiency is rare, but symptoms are most often seen in the newborn infants fed with the formula diet, which are low in vitamin B6. Also in the women taking oral contraceptives, and its deficiency symptoms also observed in the alcoholics. The activation vitamin B6 status is assessed by the activation of the erythrocyte transaminase. Toxicity, neurologic symptoms or sensory neuropathy may occur due to the utilization or taking of 2 to 7 grams of the pyridoxine per day for the variety of the reasons. Intake in excess of 100 to 200 milligram per day are associated with the neurological damage. Substantial improvement may occur, but not complete recovery occurs when the vitamin is discontinued. However, it was observed that high doses, high amount intake of the vitamin B6, there is some slight, there is effective in the treating the premenstrual syndrome. This was all about the vitamin B6.